Decide whether the triangles are similar. If so, determine the appropriate expression to solve for x. So I thought we looked at this exact problem. You have to find the other angle to make sure that they're all the same. Like that ends up being 65 degrees. That ends up being 62 degrees. And so now you have all three angles the same. But I mean, because before you don't even have two angles. You just know that 53 is equal to 53. You don't know what the B here, 65, if it's equal to B or not until you find it. So once you find the missing angle, then you can say, okay, it's AA. Then comes the part where you have to look at the answers and recognize that these are all ABC. So what does A line up with? A lines up with F. And then if you go to B, B lines up with B.
Yeah,
And
so you
then,
really got to pay attention to the angle
yes.
measurements to see which.
Okay. And then from there, like it doesn't look like you're going to get that because these are all different here. But let's just say like two of them were the same. You would then want to build a relationship with the sides. So you'd want to start with X and you'd say, okay, well, X.
Yeah, that's the part that I didn't really understand that much. I thought
So X is across from the 53. So what is across from the 53 and the other one? Well, it's Z. And then thing is you don't really know which one to go next to. I mean, a lot of them have W. So what is W? Well, W is going from A to B. That's where the letters come in handy. You want the letter going from F to D, which is R. And then if you needed to, you could solve for X by multiplying both sides by Z.
And then you get that ZX equals Z times W over R. Yeah, I kind of get how they got there now. Yeah, that makes a lot more sense.
But like I mentioned, you don't even need to get that far if you recognize, I teach this strategy and you look at the answers, say what's the same and what's different. All three of these are the same, but all three of these are different. So you only have to go as far as that to be able to answer it.
Got it. Yeah, that makes a lot more sense. Like how they got that as the correct answer. And the next one's in the chat. Now it's number 15. That's my one that I got wrong.
Take a look here. This is where AI is going to help someday be able to automate some of this. Like I already want to download and copy it and paste it into the screen. And hopefully AI will figure that out for us. So, okay. Interesting. So all of these give numerical examples here. All right, so I'll just point out, we've done this a few times. You really want to separate the two triangles and draw them separately. So you have 28x for PST. But then you have PQR. And side P to Q is 28 plus 12 or 40. P to R, though, is X plus 15.
Okay.
So this
Oh, yeah,
X
that's
plus
X plus
15 is the missing piece here. Like when you look at the answers here, only
one of them has like the problem.
well
Or well, actually,
they
both of
all
them
have,
have.
yeah, but because it's a proportion, they're using ratio with these colons. You're gonna have to have two of each, but it's always like, I call it part to whole, but really it's the small triangle to the larger triangle that are in proportion. So this 28 here goes to the 40, just as the x goes to the x plus 15.
Oh, that's what they're trying to get at there. Yeah, now I kind of get how they got that answer to the first one, where it was just the first one, just shape proportion. But that one, the first one says x is 15, and then 28 goes 28 to 40. That's correct still, but the x to 15, the part that's wrong, that's supposed to be x to x plus 15.
Right.
Because you can't really find the x plus 15 since you don't know what x is.
Well, but you can label it that way. You say, okay, we don't know what this is, but the whole thing is x plus
Yeah,
15.
got it.
You will do that in trigonometry when you solve some of these right triangles where you have to say, well, I don't know what it is, but whatever it is, it's plus 15.
Got it. So now, actually, get this other. This is one of the problems that isn't off like my question pro thing. It's more like a off one of the worksheets that like I looked up separately. But let me show you. Let me show you it very quickly. Here it's. Yeah, that should be it in the chat right now.
Okay.
It was talking about the midpoint formula, not exactly sure that the in this question. You'll see when you open it up.
Okay. PR has an endpoint and a midpoint. What is the value of the other according to the endpoint? Okay. So I show this kind of differently that I think might help here. You could graph these kind of like roughly, like where is 25 minus 5? So 25, let's just say your origin is here. 25 minus 5 is somewhere over here, and 18 minus 1 is somewhere over here. Is that okay? Clear?
Yeah.
So the other endpoint is over here. And there's a jump. And then there's another jump. Okay, now this jump, if we look at the X values, how do you go from 25 to 18?
25 to 18. That's minus 7. Yeah, minus 7.
So,
Yeah,
so you're going to subtract 7 again. This is going to be 11. Okay. Then we do the same thing, go from minus 5 to minus 1. You're adding 4.
4. Yeah.
So you're going to add 4 again. Okay. Now, this is the right answer. How do you do it without sort of doing it this way? But I like this way. This you just think of it as jump. You're jumping to the points. It's always the same jump. So the midpoint formula says the midpoint is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Now keep in mind, this is just an average. You're taking the average of the x values, the average of the y values. This is if you're given, though, the two endpoints. Okay, so if you're not given the endpoints, you have to work this backwards. Okay, so we're going to do that now.
Okay.
Which, I mean, a lot of the problems you're getting are working backwards, which is what makes them tough. So 18 is the result of 25 plus some unknown value divided by 2. Now, if we know the answer, which is 11, if 25 plus 11 divided by 2, 18, yes. Okay. But how do we solve it otherwise? Well, you multiply both sides by 2. And then you subtract 25 and you get x equals 11. Which is the same thing we got. It's just that you can work backwards or do this jump method. Same thing applies to y. They're giving you the midpoint of y. And you know one of the y values is minus 5 plus the other y value divided by 2. Now we know the answer. We know from the previous problem that the answer is 3. Is -5 plus 3 divided by 2 minus 1? It sure is. All right, so you can solve it though. Multiply both sides by 2. -2 equals -5 plus y. Add 5, y equals 3.
Got it. And if you put that together, you get 11 comma 3, or the x and the y, which is
Yep.
essentially what we got there using the.
I call it the jump method. I mean, it's the same. It's like when we take steps. If you ever like climb up steps, you always go the same amount each time
Yeah,
typically, and it's the same idea. Um, but
this method is definitely easier to grasp.
So you've
The
noticed that I'm doing a lot of drawings. I really hope you are doing some of the same. Like if there's one thing to take away from this course, it's like make a picture. Like you're finally at a point in math where making a picture is important. So
God, it's kind of key to like draw it out for yourself and kind of visualize
yep,
it.
yep. So like and look, I'm not like putting these if you go into engineering, this is what we do on whiteboards. We don't like it doesn't need to be exact. You just say there it is, it's there, it's there. I mean, it could be the Earth to the sun to another galaxy, but it's never going to be exact. You're just roughly trying to get a visual of it.
Got it. Now, there is some concepts I like to go over. I don't necessarily have word problems or anything like that for them, but just understanding the base concepts that they're based off of, which is what the problems will be asking of. One of them is the hinge theorem.
Okay.
Uh, so here it has some notes on that, but still don't
Look
quite
that one up.
understand like what it is sort of. But let me just put a screenshot of like let me put a screenshot of it in Dutch.
Hinge theorem. Okay.
Yeah, but
Typically used to determine like which sides or angles are longer in triangles.
and another thing is between the subpoints, because I got a couple of those questions wrong earlier. When they're talking about between the subpoints. So if you explain that a little more, that'd be helpful. So yeah, if you go over between the subpoints, and you do some practice with that.
I guess I'm not sure exactly what do you want me to come up with something with the hinge theorem or something?
Yeah, I guess that'd be kind of helpful going over some problems about hinge that use the hinge theorem.
I mean, these probably are not going to be advanced enough for what because the common example is this is 3 and this is 4. And so there's another side there, which happens to be 5. Now Now, if you, and that's 90 degrees. Now, if you increase the angle, and that's still 3 and that's still 4, then this new side is bigger than 5.
So is that like the essentially what it is?
Yeah, now I'll snip it in here as what its
Got it.
definition is, but it's not, it's typically used so that you can determine which angle is largest or which side is largest. So the hinge theorem states that two sides of two triangles are congruent and the included angle is different, in this case 90 versus obtuse, then the angle that is larger, this one, is opposite the longer side. Okay, that's it.
Okay.
And so what that moves to is the largest angle is always across from the largest side. Okay,
Got it.
so if I give you a triangle here and I tell you this is 14, 15, and 16, this is A, B, and C, you're supposed to say, oh, angle B is greater than, I mean, I put those. So angle B is greater than angle A, greater than angle C.
Got it.
And similarly, if I give you angle measures, if I tell you that this is 64 degrees, this is 60 degrees, and this is 56 degrees, and again, A, B, and C, so the biggest side is BC, the next biggest side is AC, and the next biggest side is AB, because the largest angle is across from the largest side, smallest angle is across from the smallest side. So that is apparently the hinge theorem.
Got it. So the next thing I'd like to go over is the converse of the Pythagorean theorem and how to prove the converse of the Pythagorean theorem. Because that came up a lot too.
Well, let's start with the Pythagorean theorem. What does the Pythagorean theorem say? If you know.
Um, so it's been a while, but so basically it's to find the hypotenuse or find one of the sides, the leg or the hypotenuse. And you'd use a squared plus b squared equals c squared to find, well, you'd use that to either find the hypotenuse or one of the legs.
So it's I would say more generally, I would say like if a triangle is a right triangle, okay, then a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse.
Got it.
That to me is the Pythagorean theorem. Now this converse comes up a lot in proofs, okay, and it's essentially working it backward. So you start with this part like on the right here, which I can't seem to get my mouse to. Right here. So it would be like this. Let's say you had a triangle A, B, C, and you found that a squared plus b squared equals c squared. Well, therefore, then this must be a right triangle. Okay, and this is the converse does not allow the presupposition that it's a right triangle, whereas the Pythagorean theorem presupposes it's a right triangle. It's like if it's a right triangle, then this.
Got it.
But the converse always starts with the output of the original, which is like if this thing is true, then the what's called the what is it called? Sorry, I just gotta look this up. Okay, so in this original one, the hypothesis is that it's a right triangle. The conclusion is that it's that this is a squared plus b squared equals c squared. The converse is that starts with the conclusion to prove the hypothesis.
Got it.
And we do this a lot in life. Not sure I can think of a great example, but we'd actually do this quite a bit. We use the converse a lot.
Got it. All right. And there's one more thing I want to go over. Is how to prove vertical angles or the vertical angle theorem.
Vertical angles are congruent.
Yeah,
How to prove that?
yeah.
Okay. You sure you don't have any questions you want to do? I mean, this is like a thing that it's like almost always um, like just given. You just accept it. But the way that I believe that this works is, let's start with 1 and 2. So we know that measure of angle 1 plus measure of angle 2 equals 180. Why is that? What allows that? Do you remember what allows that to be true?
Supplementary angles, definition of supplementary angles.
So it's actually definition of a linear pair.
Oh
Linear pair
yeah,
is
right.
supplementary, but that is what it is. So then you have that, and then what you do here is you just kind of expand the drawing a little bit, okay? And you put 3 there, and you say the measure of angle 2 plus the measure of angle 3 also equals 180 by the definition of linear pair.
Got it. And that and you kind of that it,
And you can manipulate this to get it so that uh, that you end up getting measure of angle 1 must equal the measure of angle
yeah, I
3.
think I've seen this before in a couple of like the notes and everything where they kind of
So you
explain
get
that like these two angles equal this, these two angles equal this. So the,
so you get the measure of angle 2 is 180 minus the measure of angle 1, and then you get the measure of angle 2 equals 180 minus the measure of angle 3. You set them equal, so you get 180 minus the measure of angle 1 equals 180 minus the measure of angle 3. You drop the 180s, you switch sides, you end up getting that they are the same, which is vertical angles are congruent.
got it. Yeah, yeah, that makes sense. Oh, I was kind of confused on how you would prove that because yeah, I always
Yeah,
thought like
wait,
oh,
what was your question? I'm sorry, I didn't catch it.
no, I was just like saying that explains it a little bit more because just saying it that kind of clarifies it a little bit more because before I thought that you didn't really need to prove that vertical intercurrent. That's more of like a give. It's not usually given though. Or,
Yeah, it's an early proof though. Like if you could go back 2 weeks, this is one of the earliest things you might try to prove. Um, the other one is like if I give you a line segment and I tell you that like this is like these are, let me go A, B, C, D, E. If I tell you that AC is congruent to CE, and I tell you that B is the midpoint of AC, and B is the midpoint of CE, you can prove that like AB equals DE, usually using the same, or BC equals CD or DE. You can prove them all because you're kind of limited in the beginning. Like what do you have? And so as you move through geometry, you start using the stuff that you used to prove. You can just like you're not going to be asked to prove vertical angles are congruent. Like from what I'm seeing, you're going to have a lot of similarity proofs, and maybe some triangle congruence proofs. But I don't think you're going to be asked to prove vertical angles. It's pretty early on in the course.
Got it. Alright. So let me just look.
I think you're likely to see questions that you've been seeing all along, stuff on your tests, some stuff on your homeworks, like they're just pulling from the same grouping of questions. Week
Yeah, it
time.
probably will be like a similar set from the they might take like maybe like 1 or 2 questions from each lesson and put it in there. Or like at least like one question from some. Oh yeah, if you go for betweenness points,
I'm sorry, could you try to, you said between points?
I put with betweenness of points here. This is what our here. Let me put. So this is like a diagram example of it, but
Between this, okay.
yeah, they don't really go over the definition of betweenness points in the course, but that I put the like picture that they guys give of it, but they do ask questions based off of it though, but I can't see the actual betweenness points thing there, but so I'm a little confused on what that sort of is.
Yeah, I mean, I've got a picture here that I think could help here. This is not my work. This is from the internet. Uh,
Yeah, I think I
between
looked at the
this,
same yeah.
yeah. If a point B is between points A and C, the length of AB plus the length of BC will equal the length of line AC if they are collinear. And that's
Collinear basically being if they're on the same line or if they're on
right,
the same.
right, right. But that it is assumed that between this, all 3 points are collinear. So it's and this applies not just to line segments. It applies to the angles. It applies to like a 90-degree angle here. Like let's say a 90-degree angle is broken up A, B, C. We know that the measure of angle ABD, the big one, ABD, which just happens to be 90, is equal to the measure of angle ABC plus the measure of angle CBD. So it's just saying that the two parts add up to the whole. Part plus part equals the whole. And you could have more than one part. Like it's not just limited to 2 parts adding up to whole. It could be 3 parts, it could be 4 parts. So the picture you just sent here, they're trying to show you that E resides on BC and E prime resides on B prime C prime. And therefore EC plus EB equals CB. And E prime C prime plus E prime B prime equals C prime B prime. That's it.
Got it. So wait, wouldn't it technically, well, actually no. I was gonna say, actually, so basically it's explaining that you add up two segments that are split with the midpoint. If you add both of those segments up, you get the length of the whole segment. Essential, or the whole, so that's basically what it's saying.
Yes, the two parts add up to the whole.
Got it. So I also like to go over this, the isosceles triangle. Actually, wait, 1 second. Let me see something. Wait. Actually, let's see. 1 second. Let's see something. Wait. Um, 1 second. Let me just. Okay. I don't think we went over this one, but I'm kind of like to review it again.
Sure.
I don't think we did though. So it's in the chat right now.
All right, got it. All right, square t was translated by the rule x plus 2, y plus 2, and then dilated from the origin by a scale factor of 3 to create a square t prime. Which statement explains why the squares are similar? Okay, so let's just draw a square here. And then it's moved to right, and then to right and 2 up. So it's going to end up looking, I'll do a different color for that. It looks like this, and then it's dilated. So let's just assume that's the origin. It's dilated from the origin by a scale factor of 3. So everything's going to get, it doubles in size and essentially moves roughly. So 1, 2, 3, 4, 5, 6. So something like this. 1, 2, 3, something. 1, 2, 3, 4. Okay. I feel like I didn't go out far enough on the right. That's why it's looking so weird. Okay. So there's roughly your progression, and just point out again, drawing it really does help. Grid paper really does help. So if you just count, the sides are in proportion. This is 6 and 6. This is 3 and 3. Okay. So the question is like, well, what preserves? So it does say betweenness of points in there. Notice, I hate doing this way, but notice that congruent. This is the only one that says proportional. I hate doing that, but it is important here that, because the new, whenever you dilate, the dilation never creates congruence. It's only proportion.
Got it. Because I thought that I thought that translations, oh wait, such relation and dilation preserve orientation. Then it says that squares t and t prime are congruent. Yeah, I can kind of see that because when I was doing this, I didn't really quite know what betweenness of points was. I thought that that was wrong, and that because others you
Well,
said
they do. So here's what it means by betweenness of points. So let's call this A, and this B, and this M. Do you agree that M is between A and B?
yeah.
All right. So now in the new one here, this is A prime, B prime, M prime is still between A prime and B prime. That's the betweenness.
So that's what they mean by preserving the betweenness of points.
Yes. Yes.
I thought like it meant that it had the same exact like. Oh yeah, that makes sense. Yeah, I think visualizing it definitely helps. So
I'll just say that, like, don't feel like we've got to use the entire time if you don't have any more questions. I mean, we can go the full time here, but don't feel like especially if you've been doing a lot of math lately. So less is
yeah,
more in some cases.
I think that's all we have for today because yeah, I think everything else that we got wrong in this like I think we've already covered. So
All right. So
I
real
think
quick, let's
that
talk quickly